Day 18 of 75, and today we crack a pattern that turns impossible LeetCode problems into 10-line solutions. Binary search on answers. Here's the trap. You're asked for the minimum days to make bouquets from a garden, and your instinct is to scan every day one by one. That's O(n) per check, and on big inputs at time limit exceeds. The fix isn't a faster scan. It's realizing you're searching the wrong thing entirely. Let me show you. Look at LeetCode 1482. You have a bloom day array. You need bouquets, each using k adjacent flowers. The brute force says, try day 1, try day 2, try day 3, until it works. But ask a sharper question. Can I make bouquets in exactly x days? If the answer is no for x, it's also no for anything smaller. And if it's yes for x, it's yes for anything bigger. That property has a name, monotonicity. False, 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 then true, true, true. The moment you see that flip point, you have a sorted Boolean space, and sorted means binary search. So we split this into two parts. First, a feasibility checker. Define can_make of days. Walk the bloom day array, count consecutive flowers that have bloomed by that day, and every time the run hits k, bank a bouquet and reset the counter. Return whether your bouquet count reached m. That's one clean linear pass. O(n). And crucially, it answers a yes or no question, not the final answer. Extracting this as a named helper is the whole trick. It separates what does feasible mean from how do I search. Now the search. Low equals the minimum bloom day. High equals the maximum. That's your answer range, the only days worth considering. Then while low is less than high, mid equals low plus high floor divided by 2. If can_make of mid is true, the answer might be mid or smaller. So set high equals mid, otherwise set low equals mid plus 1. When the loop ends, low equals high equals the tightest valid day. Because we're hunting a minimum, we shrink high toward mid and never discard a working candidate. That invariant, high always stays feasible, low always stays just below, is what guarantees correctness. Complexity. Separate the two factors. The search runs log of the answer range, log of max bloom day minus min. Each step calls can_make, which is O(n). Multiply them, O in log range. Compare that to brute force scanning every possible day, which is O(n) times range. The log collapses the range factor from linear to logarithmic, and that's the entire performance win. Interviewers want to hear you name those two factors separately, the search depth and the per check cost. Here's why this is worth memorizing. It's the same skeleton every time. Coco eating bananas. LeetCode 875. Feasibility is hours_needed of speed, summing math.seal of pile over speed, and you binary search speed over 1 to max pile. Capacity to ship packages in D days. Feasibility greedily packs items into days under a weight cap. Search runs from max single weight to total weight. Split array largest sum, 410, same partition and count check. Search from max element to total sum. For different problems, one template. You're not memorizing for solutions, you're memorizing one shape. Watch the boundary, because this is where people lose points. For minimize the maximum problems, mid equals low plus high floor 2, and you move high down on success. For maximize the minimum, you flip it. Mid equals low plus high plus 1 floor 2, and you move low up. Get that plus 1 wrong and you infinite loop, because mid keeps rounding to low and never advances. When in doubt, trace a 2-element range by hand. Low equals 3, high equals 4. Does your mid actually make progress? That 10-second check saves you. So the checklist, 2 questions, that's it. 1. Is the answer space bounded? Can I name a concrete low and high? 2. Is feasibility monotone? Does can I do it with x flip from false to true exactly once? If both are yes, stop brute forcing positions and binary search the answer itself. Write the feasibility helper first, plug it into the low-high loop second. Every problem in this family surrenders to that order. Day 18. Done. The takeaway. When there's no array to index, the answer range is your array. Make feasibility monotone and binary search it for an instant O in log in, win. Subscribe for day 19, where we tackle the sliding window pattern.